All right, so let's talk about the details of Avengers. Who hasn't seen
Lightning
it?
McQueen dies.
Who dies?
Lightning McQueen.
Just walking out now because I know
He's not. I'm not gonna say anything.
He already said Captain America, which I know his line. He said Captain America trips and falls and breaks his neck within
Yeah.
the first 30 seconds.
In the first 30 seconds, there's an ice cube. Captain America's walking along, slips, falls, breaks his neck.
It was a good movie. I just saw it last night. I'd recommend it. The credits
Seen it
are
3 times already, so
like, you know how like you're supposed to stay after a Marvel movie to see like the extra scene? It really felt like they made the credits a little bit longer this time. I mean, it felt like it was like 10 minutes of credits before that. Didn't it feel longer?
Yeah.
Did you see MoviePass is going to stop users from seeing the same movie more than once?
Okay, so here's the thing. So they made changes to MoviePass. That is not a change.
Really?
That's been since day one of MoviePass. That was the rule. The app didn't enforce it. Yeah. So, but now the app enforces that, and there's actually a bug in the app because there's a thing where they have like when you check into a movie, they have like a catch-all, like in case the movie you're seeing isn't listed for some reason, like they didn't pull the right schedule or something from your theater. They have like check in here in case the movie isn't listed. Well, so if you've done that once, now it's marked as you've already seen that movie. So you can never use that feature again. It's just off. I think the bigger thing that MoviePass did is if you subscribe now, you're limited to 4 movies a month. It's no longer unlimited.
And they bumped up the price too.
I thought it was $10 still.
Yeah, that's more than what I bought in at.
Right. But they've had some other specials along the way.
Oh, yeah.
Yeah, so I think I bought in at $6.95, but I had to pay ahead 12 months.
Mm-hmm.
So I have unlimited for $7 a month, but I've already paid ahead. So it really depends on when you bought in, but all new ones are not unlimited. It's 4 movies a month, which is still a good deal. But when you're used to all you can eat.
Yeah.
But they didn't, I mean, as far as I know, they haven't changed it for previous ones. So I still have unlimited.
until you run out.
Huh?
Until your subscription ends, and then
Yeah, then who knows? Will I be able to renew under that same subscription? Like as long as you don't change anything, does it just auto renew, or will I have to, re-up under one of their other things? But whatever it is, I mean, I'll take the amazing deal for unlimited. But even if you buy 2 or 3 movie passes to get your 12 movies a month or something, it's probably enough for most people, and you're still getting a pretty good deal. So I'm not going to complain too much.
But you and I are okay, right? Since we already subscribed.
This week.
Just this week.
Well, who knows? I mean,
You're
at
safe
this,
for now.
well, I mean, I can't speak for MoviePass. At this point, they haven't screwed over past folks, other than now they're enforcing you can't see the same movie twice, which has been a rule in their thing ever since the beginning. Yeah, so it's, who knows? Maybe next week they decide any MoviePass person's 4 times a month, and that's just the way it goes. So they'll have a zillion people calling and complaining, and I would assume that their customer service, which is already sketch, would just get worse on purpose. Because at that point, they're basically shutting down their doors, right? It's like, we've lost a bunch of money already. Everybody's mad at us. Just get the silent treatment. All right. Let's see. We're in Adam. Get rid of that. Well, I want to leave that up for next class for the other class. And we wrote our linked list steely, right? And we've tested that, and that all seems to work. We didn't have any other stuff for our linked list, right? We have our C linked list. This guy has add front, add end, remove front, remove end. We've practiced writing C stuff in multiple files. We've practiced compiling those things together, and we've made, kind of seen some of the limitations of structs as opposed to classes. Sound all fair? Do we all feel pretty comfortable now with struct stuff? And not forgetting to allocate memory for a struct that you tend to use more than one time? I think I've actually made that mistake twice now, 2 separate assignments, right? Pretty sure. Okay. So I still have one more. 3 times you lose, right? 3 lives.
happens if you're a cat? You won't-
I'm not a cat. Well, I'd be a pretty fat cat, I think. Haha. All right, so what we're looking at doing here over the last, let's say, 2 weeks, so we'll have to kind of make a small version of this since we're only going to have a couple of classes to work on this, is we want to create kind of a little server that allows one person to connect probably. We can always do it for multiple. We'll just see how it goes, but let's start off with one. And that server is going to serve a little dungeon crawler thingy. So we're going to take something that we've done a form of that in the past using Java and objects and things like that. So now we're going to take our linked list model, and instead of it being a linked list of integers, now we're going to hold something like a room or something like an NPC, something like this. All right, so the idea is we want to create something, and I like to use computer science department as our nice little example. So when we first come in, this is maybe this is CS hallway. We call that the entrance to computer science. And then here to the south is S120. Here to the, I guess we could have two different CS hallways. So we can have CS hallway 1 if we really want to plot this out. We have CS hallway 2. CS hallway 3. CS hallway 4. And then, so S120 is down here. This is S118. That's off of CS hallway 3 to the west. And then what is it, S114 up here? That's the lab. S114. We can call this CS hallway 5. And then this is going to be our boss room. Booze room, boss room. Booze room. That's where the end boss will be in our dungeon. So, and then this is, what is this room? S118D or something like that. Let's just call it advanced lab. All right. Yeah, we can call it the VR lab. And I'm going to skip this little room that's off of here. Oh, you want that room? Fine, fine.
There's 2 rooms there.
I guess technically, what do you think that first room's called?
Hot room.
So the Guardian is like this monster Pepsi machine. So this is soda room. And then what's this one? A who room? Well, what would we call it in here? Okay, yeah. All right, 3D printer. So that's the whole computer science department, right? All right. So each of these guys is a room. How would we represent rooms in C? Struct. All right. So let's think about our room struct. So a room will have a name. So we'll and a room might have a description. And then because we want to keep this relatively simple, we're not going to have time for like a full gameplay type thing. Why don't we just have a list of inhabitants, things that are in the room. All right, so for us, it's probably going to be other people. All right, so we'll have a linked list of Let's just call them players. Keep it simple. All right, linked list of players. All right, so name, description, linked list of players. So this particular room right now, this is S120, S120 classroom, whatever, and we got a whole bunch of players in the room. All right, and ideally, we'd like to attach kind of our chat ability to those folks, maybe at the end, but if we don't get to it, we don't get to it. We already wrote the chat room. Let's think about having those people move from room to room to room interactively and that kind of stuff. Okay, so that's what a room will look like. What will a player look like? Player struct? Gonna have a name. Now, we want this to be network aware. Okay, so when a user connects, they're going to probably, what is your name? They'll log in with their name. Long term, they might have passwords and crap like that, but they just have a name. And then do we need to store with the player their socket information? Because when we have this chat kind of set up in a room, whether we actually get to that piece or not, it's almost going to be the room becomes your chat server, right? So when you chat, it's only happening among the people that are in that room that you're currently in at the time. So when it broadcasts, it's going to have to go to its linked list of players and broadcast to all of those individual. See how our architecture is kind of changed? Where we have the main server, what does the server do? It kind of serves the dungeon. It maintains this linked list of rooms. But it's actually, let's go back here. What data structure would you use to represent something like this? So this is like the main entrance here. Let me just annotate this a little bit more. So this is kind of our main entrance. There does not exist a door that goes from here to here. So we have a door to the west that goes here, a door to the north that goes here, a door to the south that goes here, a door to the west that goes here, so on and so forth. So think about how the department's linked so you know that there's a door that goes from here to here, but there's not a door that goes from here to here. And there's not a door that goes from here to here either. All right, so what kind of data structure would you use to represent the rooms in the department?
Like a binary tree?
Okay. Why a binary tree?
Because you would be able to look, instead of a linked list, you'd be able to look at two different, like you'd have two leaves instead of just one node.
How many rooms connect to this one room right here?
Oh, I guess 3.
Okay. I'm still mostly happy with your answer. You want to amend it? Look, let's replace the binary with something else. What kind of tree is this actually? Binary tree specifies at most 2 children. And if we only want to support the cardinal directions, we're going to have at most 4 children. 4 children. We can invent something like a quadrary tree or something like that. But what's kind of our generic tree type where we don't necessarily know how many children we're going to have? Crickets? Really?
Which is like a tree.
Okay.
I think there's a technical name for it.
Yeah, there is. It's called an N-ary tree.
Okay.
Yeah. So we're going to represent our dungeon. N-ary tree. Is it A-R-R? Well, binary is spelled like that.
Just one R.
So N-ary is like that. It looks funny, but it's the name of it. So in any case, an N-ary tree where we allow potentially an infinite number of children, 0 or more child nodes. All right, so that's what we'd use for this guy. Now, what do we lose when we go from, let's just use those two. What do we lose when we go from a binary tree to an N-ary tree? What's the advantage of a binary tree?
Organized and easy to search.
Yeah, order, right? Binary trees, there's something very specific about the how things are organized in there. Do we need to worry about that with ours, or are we putting stuff where we want it specifically? One room's not necessarily greater or less than another room. So we can't really do the mathy thing and decide, well, technically S118 goes to the left child of this other room because that's just how it works, right? So really, this data structure, even though we're calling it an N-ary tree, which is what it would be, we're very much, so we're saying this is kind of our root node, right? And off that root node, we have a single child. And off that single child, we have two children. Off its, if you want to call this is its north child, instead of left and right, this is the child that goes to the north. We have this type of thing. So we have a west, we have an east, and we have a north. All right, from this one, so on and so forth. Now, there's another data structure that exists that we almost could use for this. In fact, you could make the argument that what we're creating here isn't necessarily a tree. And our department would actually kind of support this, this thing a little bit. What other data structure is sort of like a tree, but maybe a little bit even less organized? A graph. Okay, so what's the difference between a graph and a tree?
Trees hierarchical.
I think that's fair. Yeah, I think a tree, even though we're kind of painting ours in different directions since we're not calling it like left child, right child, or child 0, child 1, child 2, we're using the cardinal directions to label those things, but reality is we can certainly draw this thing completely hierarchical, right? So if a tree is hierarchical, what's then a graph? How would this, if we assume we could represent this as a tree, which I think we could, what would change with a tree to make it, what's one thing you can do to a tree that all of a sudden makes it a graph?
Connect one of the leaves with back of the root or something.
Yeah, so we have the portal, right? So obviously, I mean, you guys never see me use it, but I have a little turn around. we have a portal down here that I can go through this and I can shoot right back up farther in the tree. It's like a quick escape plan, right? So I can, so that allows me to effectively walk back up the tree where I don't have to traverse the hierarchy of the tree. Is there any aspect of the department that supports that kind of thing? Go ahead.
118 to 114.
Yeah, so this is almost kind of a double room, right? That lab down there, it's, kind of an elongated room. So there's a little door that comes here. So we can get to this room from this room. We can also get to that room from this room. And depending on where they are in the hierarchy, that might kind of create the little loop type thing, which would then start moving this guy into a graph type thing. Go ahead.
Couldn't you also say S120 to CS, like CS hallway 1? Because you can go out the store and go back into CS hallway 1?
Possibly, except you'd have to because this CS hallway I'm thinking is inside the CS door.
Yeah.
So you technically would then have to represent kind of the actual hallway out here in the, yeah, so this is actually probably drawn a little funny because actually S120 is kind of like here, or actually it's kind of here, and then this thing's a little fatter, but let's just stick with our Legos for this guy. But you're right. But we really only need one of these to say it's a graph. Now, does it matter whether this thing's a graph for a tree or anything like that for us? When would things like that matter? So at some point, we're just throwing around names and saying, well, this is this kind of data structure, or this is this kind of data structure, because typically we select a data structure because it's the right tool for a job. Kind of the first example you see, when you had 300, did we do traveling salesman? Or did we not get to that?
I think we started it.
Okay. So that's kind of a graph problem, traveling salesman problem. So because you have this idea where you have nodes that connect to other nodes. There's like more than one way of getting to the same place. That type of thing. But in that case, we're really talking about graph traversal as opposed to tree traversal, which have some similarities, but maybe have some differences when you start getting into some loops, right? Because you don't, if you're here, then here, then here, then here, you don't want to go back to here because you've already traveled to that city, something like that. Does that matter for us here? How important is it that we give a name to what this data structure is? Are we kind of just making our moves from where we currently are? If I'm in 120, I could take the door to the north. That's all that's important. I have a link that gets me from here to there. When I'm in there, I can take the door to the west, I can take the door to the north, I can go back in the door to the south. And they lead somewhere. It's kind of unimportant if there's loops, right? We just need to make sure the pointers are all hooked up to each other. So in our case here, even though we're representing it as a graphy type thing, we're customizing it for exactly what we're representing. And since we're not really traversing this guy from a searching perspective or a shortest path type of thing, we could, but since we're not planning on doing that, it doesn't really matter what we call it. Make sense? So this is a non-linear linked data structure thingy, okay, that we're using here. That's probably most similar to a graph, but second cousin to an N-ary tree. Something like that. Okay. So having said that, we have things in here called rooms. We're going to have players that inhabit these rooms. Now, rooms are linked to other rooms. How does that work? How, from S120's perspective, how do I create a link from here into this room? I need to make these guys connected. How do I? Go ahead.
Pointer?
Well, they're going to have a lot of pointers, but at a higher level, how are we going to keep track? So if we're implementing the struct that is the room S120, we're standing in this room right now, right? Okay, and I'm saying, okay, well, I have a collection of persons that are in this room. This room has a name, it has a description. I have some persons that are players, rather, I would call them players in this room. Then I have an exit over there. And what's an exit? You mentioned it might be a pointer that leads to another room, for example. Go ahead.
Would we use a link list too? Sure.
Yeah, we might use a link list because we have a couple of options here. If we stick strictly to just the 4 cardinal directions, north, south, east, west, then we wouldn't need to use a linked list. We can use exactly an array of 4 elements, right? But I really need to know that particular exit is to the north from in here. How do I store that? So I have a collection of up to 4 exits, even though this particular room, from the perspective of just the CS department, we're forgetting about that door, right? Has only one of those 4 exits enabled. But I want to know that exit is actually the exit to the north. How do I accomplish that? Go ahead.
Door node that stores extraction and what it's connected to.
Okay, so you want to create a struct for an exit, and the exit struct keeps track of 2 pieces of information. So he's going to create an exit struct, and an exit struct would have a direction and then a pointer to the room that it links to. I think that's fair enough. Might be a little bit tedious to kind of create but we're not creating a zillion rooms here. It's not going to be the end of the world. But so this particular room would have a collection of exactly 1 exit, right? Now, if we wanted to not stick to the 4 cardinal directions, we could say it's a linked list of exits. Not the end of the world, right? We can modify our linked list pretty easily to just change, instead of it storing ints, the payloads are actually exit structs, exit struct pointers, right? Certainly do that, doesn't really hurt anything, all right? But from this room's perspective, it's going to have 1 exit in here with The direction is north, and the pointer would lead to this other room that's out there. From that room's perspective, it would have an exit to the south. So if we come in here, this guy right here would have an exit to the south that points to this guy, another exit to the north that points to this guy, and another exit to the west that points to this guy. Not too bad. So we can have up to 4 exits in a room. So we certainly could just fill it up with, have a 4-bucket array. All right, so a room. Now, we do need a linked list of players, though, correct? Because we don't know how many players we're going to have. But we might need a struct exit array of up to 4 exits. But in all honesty, that might actually be more difficult to work with than just creating a linked list of exits. It's probably at least a wash. Because now what you have to do is you have to create your array with up to 4 buckets in it. So up to size, 4 times size of struct exit. And then you'll fill it up with a bunch of nulls initially, right? And actually it's going to be a array of struct exit pointers. Right? So it's going to be a struct exit pointer called the exits or something like that. That can hold up to 4 of those guys. But initially, it's going to be filled up with 0 pointers. And only after I start putting exits in there will it actually have real pointers in there. It may actually be more convenient just to create a second linked list of exits that allows you to hold 0 or more exits. Now, does that mean you'd have to write 2 separate linked lists? Or could we modify our single linked list to be able to hold a linked list of players as well as, so if we just kind of rewrite this and say a linked list of exits. Can I have a single linked list written in C that knows how to hold both players and exits? Let's kind of get rid of this for right now. You can certainly write it twice, right? You can have a linked list of players and a linked list of exits, but how would you implement a linked list of players or exits?
Use like a void pointer.
Void pointer. So one thing we have in C and C++ is effectively a generic pointer. Look, this thing points to a place in memory. You deal with whatever is there. Okay? So we could change our payload in our linked list to hold a void pointer. Right now our payload holds an int. We can have it hold a void pointer as the payload. And that guy might point to a room. It might point to an exit. It would then be on us to say, okay, well, when I create my linked lists for exits, I need to make sure I stick exits in there. When I create my linked list of players, I need to make sure I only stick players in there. That way, when you're pulling stuff out of there, you can typecast it back to the struct type you're pulling out of there. Because that void pointer is going to actually point to a struct that lives somewhere. That make sense? So, again, you can make this generically if you want, or you can make 2 different linked lists, which would be identical in almost every way, except one of them holds a very specific pointer to player structs versus another one holds a very specific type of pointer to exit structs. That makes some sense? All right, so a room, name, description, linked list of players, linked list of exits. It doesn't matter whether you implement these as 2 separate linked lists or you implement them as one generic linked list that you can use multiple times. It just holds pointers to stuff. Now, could you hold, we kind of think back to how Java works here. Could you hold a, how would we implement generic type linked lists like this in Java? If I wanted to hold a room object and an exit object, these are both classes in Java, let's say, how could I write a single linked list that knew how to hold both of those? Go ahead.
Linked list of objects.
Okay, linked list of objects. You can't get any more generic than that. So a linked list of objects is kind of like our linked list of void pointers, right? Can you hold int primitive types in a linked list of objects? Can you hold float primitive types in a linked list of objects? If you want to hold an integer, an int, in a linked list of objects, what would you have to do?
To make an integer object.
Yeah, you have to remember in Java we have in java.lang we have class versions of all of our primitive types. We have an integer class and a character class and a Boolean class and all those things. Now all those classes, well, first of all, do those classes, are they filled up with class methods or instance methods? Static methods or non-static methods? And then my follow-up question to that will be why. So if I were to bring up the Java documentation here, and if you're thinking about cheating, that's okay, but then you're going to have to come up with a follow-up of why. Okay, they're filled up with static methods, class methods, right? Why?
Because I call them with the class name. Is an example why I can tell you that.
Oh, so you're telling me the reason you know they're class methods is because you call them with the, it's like integer.parseInt, that kind of thing. Okay, well, so that's the side effect of them being class methods, right? I'm asking, why did the people at Sun Microsystems design them to be filled up with class methods? Did they just flip a coin?
Yes.
Super important concept of why one might choose class methods versus instance methods. 250 concept. Which is the... All right, so here we'll go to the, as you pointed out, the integer class is filled up with a whole bunch of static stuff. Okay? So then the question is why? Why did they decide?
I guess you could say that they're useful to use without instantiating. Like I want to be able to use like get integer without making an integer.
Okay, well,
Yeah.
why don't I need to make an integer? Why is it, let's say, why is it inefficient for us to create a instance of integer to hold on to an int that we then call instance methods on? Why does the string class exist? String class is filled up with a bunch of instance methods, right? And when we build a string, you pass it the string you want to hold, and then when you call the instance methods, it operates on the string that it holds. Couldn't they have made integers the same way? You build an integer, you pass in an int, then call instance methods on whatever int the integer holds. They could have done that, right? But they didn't.
Right, I mean, because were they using the primitive type for storing it?
Yeah, we already got a way of storing it. Why do I build a new way of storing a value when I already have a way of storing a value? That make sense? We already have a primitive type for holding ints and chars and floats and booleans. We can already store them. Why take up more memory to have a whole bunch of instances floating around that are just holding a container that already holds something? Instead, we'll just provide you the nice little gumball machine, or factory, however you want to think about it, where you walk up, you plop your int into it, and it does whatever you asked it to do. Convert this to a string. Convert this to Boolean. 0, 1, that kind of stuff. That make sense? So they made that decision for a rational reason, not based on a coin flip. They said, we already have the ability to store an integer. Therefore, we're not going to build this object with that in mind, but we do need to operate on integers. Why do we need to operate on integers? Why do we need all these functions to do things to integers? What's the definition of a primitive type? We got to go back to our 250 chants. Who's going to play the drums? Primitive type is a type built into the language that's only capable of holding a value. Only capable of holding a value. It can't do anything else. It's all it could do. It doesn't have functions and things like that associated with it. It's really good at holding a value. Can't do anything else. So we need, if we want to do things to ints or do things to floats or whatever our type is, we need to provide a set of functions for operating on those guys because they don't have those functions themselves because they're primitive types. But we don't need to provide a means for storage because they already know how to store themselves. That's just being efficient. Now, we could just say, well, it's convenient that let's just create, like, why do primitives even exist? Why didn't Java just say, well, look, if you want an int, you build an integer. Now you have an int. Why did they do that? Wouldn't that have been more convenient than having these two different kinds of animals? We got this primitive type thing that's floating around here that are just really, really limited on what they can do, except they can hold values, but it's fine. That's kind of boring, but also necessary. And then you have these object types that are like superstars, right? They're super objects. They're super variables. They can do all sorts of stuff and hold values, more than one value if we want. Why didn't they just say, look, we'll just, if you want an integer, you create an integer and pass it the int. Now you have an object that can do all sorts of stuff. It's magical.
Keeping it lightweight is going to be better for, I guess, efficiency of taking just the value as opposed to going through everything, I would say.
Okay, there could be some memory benefits from that, and
Well, I think it would run faster too.
Potentially, yeah. I don't think it would be fair to say you're wrong. I think that there might be a performance benefit. But I think there's probably one overarching reason. This goes back to that whole 200, slide where top language, where I always start kind of is at C, right? That goes to C++, then goes to Java and C# and blah, 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 blah. Well, Java came from C++. C++ had ints. C++ came from C. C had ints. They're not rewriting the whole language. They're dealing with a language that already has all these primitive types. Now, they can reimagine the language. Or they can say, look, first of all, I have this language, let's call it half written for me. I just need to say, I need to Javify it, right? And then on top of that, you also have to consider the people you're hoping to convert over to your new religion, okay? the new Java language. And they already are used to writing stuff in C++. They're going to be used to using ints and doubles and floats and all that kind of stuff. So you could say if they were reimagining a programming language from the ground up, that maybe they do just do everything as objects. That make sense? But one limitation we have with Java is that if I want to create a linked list of generic objects, like you suggested, to hold, let's say, quote, anything, it only holds almost anything. It holds anything that is of object type, not our primitives. But it just so happens that you can build, if we look at the constructor for integer, you can build an integer passing it an int value. You could also pass it a string value, string version of an int. So you can create integer objects using int primitives and string primitives. Strings get a little weird in Java, but in any case, you can do that. Yet, a lot of our methods here, notice we have some methods that allow us to compare to other things or get byte values out of stuff, but most of our methods in here are static. The only reason that that constructor exists is when you need to deal with an int as an object. Okay, it's kind of like getting a little Ziploc bag out, tossing your int in there. Got an object. Handle with care, right? And now you can store that because an integer is, here's the class integer. That guy is a number, which is an object. That make sense? All right, so in Java, we actually have to take that extra step because we've added this brand new complication that is objects to our language. And now we have this, this distinguishing, we have this difference between objects and primitives. Where in C, that wasn't a thing. Everything's kind of a primitive. I'm not even sure they necessarily thought about them as primitives. It's just that's a variable type. That's what we have. It's right there. So in C, we can be super generic and just say, hey, we're going to create void pointers. Give me whatever you want. I can store it. Make some sense? All right, so for our homework as a starting point here, we want to create, let me get a player struct created here real quick. So a player is going to have maybe just a name for now. We can always add that, something else. Because I think we also said maybe it has the socket ID, which is just going to be an int. So you could say int socket ID if you want. We're not using it yet, so it holds those two pieces of information. Okay, so it's going to hold a name and a socket ID. So what we want to do is we want to, for homework, create a single linked list based on our current linked list. So it should have all the functions we already have. And if I didn't paste it up there, did I put that up on Slack already? I'll put it up right after we're done with class. All right, so create a linked list based on our current linked list that is capable of holding exit structs as well as player structs. And really, it's going to be capable of holding anything that you want to put in there. Okay, but our intention is going to be able to hold player structs and exit structs. Make sense? All right, and test thoroughly or something like that. Questions, comments, concerns, bribes. Shouldn't be too difficult, but the practice for this is going to be dealing with some of that memory. And then we also get to look forward to me forgetting to malloc or something next time. So it could be big fun. All right. I will put I'll put the assignment up, and I'll also put the current version of our linked list up on Slack so you have that to work off of. All right. I'll see everybody on Wednesday.